Hey, everybody. Hoping you did well on this homework, but you're just here to double check your answers and look for any possible mistakes, right? If you did have trouble, hopefully you were able to ask your teacher and you're not waiting until this video comes out after it's due. Um, when the video is mostly, it's to help you, yeah, but it's mostly to help you after you've tried it and to let you know if you made any mistakes. So let's check it out, see how you did. So that first problem, 6-96, we were supposed to get the perimeter, and I helped you with that, but we didn't write it all out. So let's say I start right here and go clockwise. That's a 1 plus x plus 1 plus 1 plus 1. So I'm going to write 1 plus x plus 1 plus 1 plus 1. And then plus x plus x plus x plus x plus x plus x. Now, when I get all of that, I want to simplify it, okay? And we talked about what that is, combining like terms. I'm going to put all the x's together and all the ones together. I'm adding them all, right? So I'm adding 1, 2, 3, 4 ones. So that's 4. And 1, 2, 3, 4 x's. So that's x times 4 and 1 times 4. Well, we can write that as 4x plus 4. Okay? Okay, same idea here. Let's pick a spot. Let's go right here. Start in the top left corner and go around. 1 plus 1 plus x plus x plus x. 1 plus 1 plus x plus x plus x plus 1 plus 1 plus x. 1 plus 1 plus x. And again, it looks like I have 1, 2, 3, 4 ones and 1, 2, 3, 4 x's all getting added. So check this out. The perimeter for this is 4x plus 4, and the perimeter for this is 4x plus 4. And you think, how does that happen? Well, that one little thing sticking out sort of makes a difference, huh? Yeah. Here the 4 ones are here, 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 and here. Here the 4 ones are here, 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 and here. Okay. All right. All right. On to the next problem. Jack and Jill playing mystery game. And again, we decided that this mystery game is a combination of Connect Four and graffiti. Right? Okay. So we needed to find all the points that Jack had already or Jill had already put on there. Those are the red ones. 1, 5, over 1, up 5. So we got that one. 2, 4, over 2, up 4. Okay, how about this one? Over 3, up 3. And then over 4, up 3. Over 4, up 4. And this last one, over 5, up 3. Okay, that's all the points that Jill already has. Okay, let's go ahead and get the blue pen out for Jack. We have 1, 2. We have 1, 3. We don't have that 1, 4 yet. So let's add the 1, 4. And then the next one over 2, up 3. And then over 3, up 4. So he only has 5 dots. She has 6. It must be his turn. Now it says we give 2 more points, 1 to Jack and 1 to Jill, so that either might win the game. And we have choices here. If you're supposed to get 4 tiles in the same row or column or diagonal, then where could Jack go? Well, you see any spots? Well, I say he can go right here, right? Because that would have 4 in a row going diagonal. So 1, 1. This is answer B. 1, 1 for Jack. But you can also go straight down here. Sorry, that's 1, 1. You can 0, 1 for this one, right? 0, 1 and 1, 1. Either of those work. But check this out. You could also go up here. Over 4, up 5 would get you 1, 2, 3, 4 in a row. So there's 3 choices for Jack. How about Jill? Well, I see these 3 in a row right here. So I know you could go 6, 3. 6, 3 works for Jill. Any more? What if I went here? You see, that's only 3, but check this out. There's 3 more going that way. So I can go right here, okay, and get 4 in a row going diagonal. So that's over 4 up 2. And any more? Yeah, that diagonal, I could have gone up here. Over 0 up 6. So 3 choices for either of them to win if they go next. Okay. All right, 6-98. This one we have Molly and Nancy, and they both did their problem and got different answers. 2 plus 3 times 4. Now, which one is the one that's right? Okay. And actually, Molly is wrong here. Okay. She went out of order. What does that mean? She added before she was done multiplying. In this problem, 2 plus 3 times 4, you're supposed to multiply before you add. So if I multiply before I add, I get 3 times 4 is 12, and then 2 plus 12 equals 14. So Nancy was right, Molly was wrong. And the reason is because of the order of operations says you're supposed to multiply before you add or subtract. Now, if Nancy had put this in parentheses allows the addition to take cuts in front of the multiplying. Then you would get 2 plus 3 is 5, and 5 times 4 equals 20. That would be correct. Okay. All right, 699. You got 3 pieces of licorice that are blue licorice. You're dividing into 4. Okay, let's say we have our 4 people, A, B, C, and D. Those are the people. Well, let's say A gets this piece, B gets this piece, C gets this piece, D gets this piece, right? A gets this, B gets this, right? And it looks like now all 4 of these people each got 3 of these pieces. How big is each piece? Each piece is a fourth. So 3 divided by 4 equals 3/4. And that makes sense because your teachers have been telling you for a while, fractions are just like division problems. You divide the bottom into the top. Okay, so 3/4 is the answer there. 6-100. Okay, find all the factors of 24. 1 times 24, so 1 and 24 factors. 2, it's even, so I know 2 goes into it 12 times. How many times does 3 go into it? 8 times. Now, it was 2 times an even number. That means 4 is going to fit into it. How many times? 6. And see how these numbers get bigger, why these numbers get smaller? And the only number between 4 and 6 is 5. Does 5 go into 24? No. So I'm done checking. I got all of the factors of 24. I say factors fit. I had a friend that used to teach, and she used to always say factors are finite, right? That's the opposite of infinity. There's a finite numbers. You know when you're done. So all the factors of 24, you want to list them. 1, 2, 3, 4, 6, 12. Whoops, I missed the 8, huh? 8 and 24. And the next question is, what number has 1, 2, 3, 4, and 5 as a factor? And we decided that every number that 4 goes into, 2 goes into, we don't have to care. We don't care about that. And 1 goes into everything, so we don't care about that. But to find a number that 3, 4, and 5 both go into, that's where it gets tricky. And for 2 numbers right next to each other, the trick is you multiply those. The smallest number that 3 and 4 go into, since they're right next to each other, is 3 times 4. And 3 times 4 is 12. The smallest number that 4 and 5 go into is 4 times 5. 4 times 5 is 20. Okay. Now, the smallest number that 3, 4, and 5 go into is 3 times 4 times 5. 12 times 5 is 60. Are there any numbers smaller than 60? All right. That all 3 of them go into, because 5 won't go into 20 and 5 won't go into 12 and 3 won't go into 20. 3 times 5 times 4. Now you notice this isn't 12 times 20. It's smaller than that. So that helps us to just go 3 times 12, 3 times 4 times 5. Okay. All right, so 60 is the smallest number they both go into. If I double 60, I get 120. That's going to be the next smallest number all 5 of them go into. And again, if you're looking for numbers that other numbers go into, we call them common multiples. Common multiples. And if you have the absolute smallest common multiple, you have what's called the least common multiple, and they often will refer to that as the LCM, least common multiple. Okay, all done. That's it. All right. Have a good one, everybody.